In this video, we're going to be introduced to the concept of the mole, and we'll learn that chemists often refer to the mole as being the equivalent to the chemist's dozen. We group numbers all of the time, and the reason why we group them is we like to make them more manageable. So for instance, if we were talking about eggs, we group them in dozens. Socks we group in pairs. Paper sometimes is grouped in reams. If we go back, dozens are 12, pairs are in twos. Reams of paper are actually groups of paper of 500. So when you collect a package of paper to put into the photocopier, that's a ream of paper. So chemists have their own way of grouping numbers, and it's their way of grouping atoms and molecules. And chemists group atoms and molecules by the mole. And the mole is equivalent to 6.02 times 10 to the power of 23 particles. So that's a really big number. And it's really hard for us to wrap our heads around how big that is. Another way of saying this is that a mole is 6 sextillion particles. A really great resource to figuring out how big a mole is to watch the TED Ed video titled "How Big is a Mole?" So I would recommend actually pausing this video and watching that one and then continuing on with this video. So like I said before, we often call the mole the chemist's dozen. And the question is, why would we do that? Well, the mole, like you now understand, is a really, really big number. And if we just call that really big number a mole, it'll be easier to manage than naming the number of particles that are in each thing, because that would be very, very difficult. So each substance has a different molar mass because the atoms that make up that substance are bigger or smaller than one another. So molar mass is the mass of 1 mole of a substance in grams, and it's equal to the atomic or the molecular mass, but calculated in grams. So for an example, the atomic mass of a hydrogen atom is 1.01 units, atomic mass units, and the molar mass of one hydrogen atom is 1.01 grams. Now, if you had 1 mole, so 6 sextillion atoms of hydrogen, that would only weigh 1.01 grams. So that gives you an idea of how tiny the atoms of hydrogen are and how tiny particles are. We can't look at them under a microscope. They are way too big to do so. So grouping them in terms of moles is much easier to work with. So to calculate the molar mass of a compound, we would have to add up all the molar masses of each atom in the molecule. So the example that we're going to work with is water. So the molar mass, and the symbol for molar mass is a capital M, is equal to, there's 2 atoms of hydrogen, so it would be 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. So we sub the values in, so 2, and we look up on the periodic table, and the molar mass of 1 hydrogen atom is 1.01 grams per mole, plus 1 times 16.00 grams per mole for oxygen. We look that up on the periodic table, and that would add up to 2.02 plus 16.00. That combines to become 18.02 grams per mole. And that is the molar mass of water. So 1 sextillion molecules of water would weigh 18.02 grams. So a nice visualization activity I like to do is weighing out or calculating how big a mole of different substances that we find around the house are. So for this example, I want you to calculate the molar mass of each household chemical, and then if you have a scale, weigh them out to see how big a mole of each of those substances would look like. So the examples I want you to try are salt or sodium chloride, water, H2O, which we've already calculated, sugar, which is C12H22O11, so that would be sucrose or table sugar. Baking soda is NaHCO3, and magnesium sulfate is known as Epsom salts. So calculate those molar masses, and then so pause the video right now and then calculate them. Check your work on the next slide. So now we're going to check our work. So if we take a look, the first one we have sodium chloride. So that would be the molar mass of sodium plus the molar mass of chlorine. So 22.99 plus 35.45. And that totals 58.44 grams per mole. We already calculated the molar mass of water, but I put the solution here again. That's equal to 18.02 grams per mole. For sucrose, so also known as table sugar, that's equal to 12 times the molar mass of carbon, plus 22 times the molar mass of hydrogen, plus 11 times the molar mass of oxygen. That equals a grand total of 342.34 grams per mole. Sodium bicarbonate is equal to the molar mass of sodium, plus 1 hydrogen, plus 3 oxygens, plus 1 carbon. That equals 82.01 grams per mole. And then magnesium sulfate or Epsom salts is equal to the mass of a magnesium, the mass of a sulfur, and the molar mass of 4 oxygens. So that's equal to 120.37 grams per mole. Now, if you have a scale, you can weigh out those samples and see the differences between them.